student in DIT studying engineering. I'm currently an electrician, but I chose this course to try and advance my career. I'm a member of Group Power Factor, and I'm the one who's going to actually do the experiment with you and show you how simply but effectively you can make your own compass using household items. Thank you.
Hi everyone, my name is John McCarthy and I'm currently studying to be an electrical engineer in Kevin Street's DIT. Previous to this, I've been an electrician for 18 years and I enrolled in this course to help advance my career. I have to say I'm really enjoying my time here and I would recommend this course to anyone that's interested in any type of engineering role. I'm going to pass you over to Colin now, but I will be back shortly with some sciencey stuff.
Hi, my name is Colin. I'm an electrician. I'm part of Team Power Factor and I will be talking about the safety requirements for this experiment. I will also have a list of materials involved in making this experiment possible. After giving a brief explanation of the build of this experiment, I'll be handing you over to Simon.
Hi, how's it going? My name is Jared Fennell. I'm an electrician and have been for the past 20 years. I'm currently working for the designer group. As well as being an electrician, I'm studying electrical service engineering at night in Kevin Street, course DT078. Part of our course curricula is to do a video assignment for professional development and key skills, and it has to do with something with science. The group I'm doing the assignment with is called Group Power Factor, and it consists of myself, Simon Kelly, Colin Riley and John McCarthy. The video presentation that we're going to be doing is based on making a compass out of household equipment, and it's going to be called DT078. So please be careful if you try and replicate it. Thank you. Bye.
As promised, time for the sciencey stuff. Right, what we're going to cover here is 4 different sections. First off, what is magnetism, what is a magnet, Earth's magnetic field, and how does our experiment work. Right, so what is magnetism? Magnetism is an invisible force. It can attract or repel objects which have a magnetic material. An example of this material is an object that contains iron. We call this material magnetic objects. In simpler terms, it's a property of certain substances which pulls close or pushes away other objects. What is a magnet? A magnet is an object that gives off a magnetic field. Basically, it applies an invisible force over a distance onto other magnets. There are a number of different types of magnets, but for now, let's keep it simple. We'll be sticking to our standard bar magnet. I'm just going to turn around to the screen now just to show you. What we have here is we've got a bar magnet and its fields. Here's our north, here's our south, and as you can see, it's our invisible fields are going from north to south. So, and that's that. Next, onto our Earth's magnetic field. The Earth's core is a mixture of iron and nickel. This gives the Earth its own magnetic field. Earth's magnetism extends nearly 60,000 kilometers out into space, so you could call the Earth a supermagnet. Just like our simple bar magnet in the slide previous, the Earth has a north and south too. The north side of the magnet or compass will point towards the Earth's north pole, and the same happens to the south pole. I'm just going to turn around to this again. So here we have our super magnet, as we like to call it, and if you look at it, it's similar enough to what way a compass will look like if we have this piece thrown in, and as we can see here are invisible fields flowing from north to south. So how does our experiment work? It is now our understanding that the Earth's core is a gigantic magnet. What's left to do is to magnetize an object and let it spin freely until it points north. To do this, we will use a magnet to magnetize a sewing needle by stroking the needle from the bottom to the top with the north end of the bar magnet approximately 30 times, and lifting between strokes, it will put the needle's iron atoms into alignment. This in turn creates a weak temporary magnet, and there you have our compass. Now we know what magnets, magnetism and Earth's magnetic fields are. It's time to have fun with the experiment.
During this experiment, we have to make sure we take into account the necessary safety precautions. As we are using a sharp needle in this experiment, Adult supervision is absolutely necessary to ensure safety steps are executed. When we have a responsible adult supervising the experiment, we can start with getting the items required to make sure the experiment is possible. The required materials are a needle, a magnet, a real compass to compare, a cork and a bowl of water. The build of this experiment involves filling a bowl of water, placing the cork into the water to float, then we get a needle and rub the needle against the north side of the magnet, which allows the needle to have some magnetic energy. We then place the needle on the cork and the experiment is ready to compare against a real magnet. Simon now is going to produce the experiment.
Okay, so now to actually do the experiment. So first you get your pin and your magnet. So you can see here it's clearly marked north and south. So what we're going to do, and it doesn't matter which way you do this, if we get the north and just rub it 30 times. Important that every stroke you make is the same direction. That just transfers the magnetism from the magnet into the pin. Then we get the cork and we sit the pin on top of the cork. And let it float. It should come to rest pointing the same direction as our compass. Move it and it should come back to that position again. And there you have it, how to make a compass from a pin. Thanks for watching.